back of that supplemental, 4 notes, just the add-on. So these next 2 types of questions are just asking you to identify the special segments when there's more than one in the picture. So you've got to know the difference between median, altitude, perpendicular bisector, angle bisector, and mid-segment. So remember, the mid-segment is the one we spent the most time on, and it connects midpoint to midpoint. And I know that A and E are midpoints because of these tick marks on the segments. So A is a midpoint, E is a midpoint. So midpoint to midpoint is mid-segment. Okay, and then what you want to know about the mid-segment is that it is parallel to the third side, the one that it's not touching, and it's half the length of that third side. Okay, and then the next one, KB. So K is a vertex, and B is down here. Now, the way that they drew this, it's not real clear, but they are saying that MB has 3 tick marks and BP has 3 tick marks. That's what they're marking congruent. I know there's this extra segment drawn in there, and so some of y'all might be confused by that, but they're saying MB is congruent to BP. So the fact that those are marked congruent means B is a midpoint. So vertex to midpoint, that's your median. So midpoint to midpoint, mid-segment, vertex to midpoint, median. And the median is just a segment bisector. It cuts that segment in half. And then the other one in this image is KN. So again, K is a vertex. N is not a midpoint. It's just a point on the opposite side, but they do mark it as perpendicular, a 90-degree angle. So you need to remember, if you go from a vertex at a 90-degree angle to the opposite side, that is the height of the triangle, the altitude. It does not bisect the side. It doesn't cut the angle in half. It doesn't bisect anything. It just measures the height of the triangle. Because remember, the height and the base have to always be perpendicular. In this example, this one has some different ones, some of the same, some different. So there's another altitude. We go from a vertex to the opposite side at a 90-degree angle. That is an altitude. So in this one, Kn is the altitude. Now I see another 90-degree angle here with CB, and CB makes a 90-degree angle, and it's cutting this side MP in half. That's what those 3 tick marks are telling us. So CB not only is perpendicular, it also is bisecting because it's going through the midpoint. But notice it doesn't come from a vertex. So this segment CB is a perpendicular bisector, and perpendicular bisectors do not have to go through the vertex. They can, but they don't always or have to. That cut off, but that says bisector. All right, and then WP, this one is going from a vertex to the opposite side. Now, it doesn't tell us anything about that opposite side. There's no tick mark, so I don't know if it's bisecting MK. I'm not going to assume that, but I do have arc marks on this angle that's split. So this angle KPN here is split by WP into 2 equal pieces. So when we cut something into 2 equal pieces, it's bisected and it's an angle. So WP is an angle bisector because it's cutting an angle in half. So our special segments are angle bisector, perpendicular bisector, altitude, median, and mid-segment. So those are the 5 special segments that we learned about. All right, and then last but not least, this is similar to one you saw on the quiz and hopefully have done in your quiz corrections, but I just wanted to add one to some notes for y'all so you had it all written out and drawn out to keep with your notes. So you can start from the left or the right, but we have to work our way in. Okay, there's more than one way to do this. And just like I talked about when I went over the one like this on the review, you can use triangle sum. So you do have to know triangle sum theorem the triangle angle sum theorem, I should say, is that the three angles add to 180. So yes, I could use that to find this missing angle and then use the fact that these are a linear pair to get angle 1. But a quicker way is to realize that 1 is an exterior angle. And if you know the exterior angle theorem, it says that the exterior angle is equal to the sum of the opposite two interior angles. So I can simply add 29 and 82 to get the measure of angle 1. And it will come out the same if you do the triangle sum theorem and then linear pair. You'll get the same thing. So it's 111 degrees. Come on in. I'm recording, but you can come in.
Thank you.
I'm almost done. So I know angle 1's 111 degrees. So then I can use linear pair to find angle 2, because 1 and 2 form a line together. So I know that together those should be 180. So I can subtract the 111 from 180 and see that it should be 69 degrees. This is 69 degrees. Now I can't go any further right from there. So now I have to go over to the far right and work my way back toward the middle. So over here, and I'm going to put the reason, my justification. So what I did in red was the exterior angle theorem. The exterior angle is equal to the sum of the opposite two interior. And then what I did in blue was because they are a linear pair, which means they are supplementary. They add to 180. Okay, so now I'm going to come over here to the right and I can do exterior angle theorem again, because 142 is an exterior angle. So it's going to equal the sum of these alternate two interior or opposite two interior angles. The only thing is, instead of missing the exterior angle, so just adding and having my answer, I have to work backward because I know that these two should add to 142. So I just work backwards and say 142 minus 68 to see what's left, which is 74. So this angle is 74 degrees. So again, I used exterior angle theorem for this side as well. Now, both what I did in red and in green could have been found by doing a linear pair and then triangle sum. And here I could have done triangle sum and then a linear pair. So both of those would have worked out and that would have been fun. And now here to get to angle 4, I need to know that these angles that are opposite each other at an intersection, these are vertical angles. Vertical angles are congruent. So angle 4 will also be 74 degrees. Now I can use that triangle sum theorem to find angle 3. So the triangle sum theorem says, okay, I've used 69 and 74. So I've used up 143 degrees. And the triangle has to add to 180. So that leaves me with 37 degrees for angle 3. And that's that. So to answer these, it helps to know exterior angle theorem, but you have to know triangle angle sum theorem. You have to know linear pairs or supplementary, and you have to know vertical angles are congruent. And then you're able to solve those. Okay, and then if you still needed page 1, that's in a separate video. I went over perpendicular bisector theorem and this last one with overlapping triangles as well.